Hey guys, welcome to Mr. Harjo's Math Channel. Be sure to like and subscribe and hit that notification bell so you never miss a new video. Just kidding. You don't have to hit any notification bell or like or subscribe. We are just going to fill out the second set of notes. The first bit was in our module notebooks. Well, I think for this time period where we're online, I think I'm going to go back to my foldables that you're going to have to download. So you're going to need this foldable while you watch the video. If you don't have the foldable with you or you couldn't print it out, just watch the video and then you can go on to Khan Academy or go into Schoology and check for the corresponding homework that's going to link to Khan Academy and Delta Math. Now this set of notes is just basically a lesson on formulas for volume of pyramids, cones, cylinders, and spheres. So it's just formulas, not too crazy difficult. We've already had the lesson on area, and we said that area is simply length times width, and with area our units are always squared, and we're counting square units. Well, volume has that general formula of length times width times height. Our units are now cubed because it's three-dimensional, and we're counting cubic units. All right, so with area, we're counting how many of these squares fill a space. With volume, we're counting how many of these cubes fill a space. All right. Just a few things to get out of the way, some terminology, and then we can get into the formulas. So first, we say, what's a prism? Well, a prism is just a polyhedron. That means it's a three-dimensional polygon, essentially. That's got two congruent and parallel faces, and those two congruent parallel faces we call the bases, the top and the bottom. And there's two general types of prisms, right and oblique. Oops, there we go. Okay, so oblique just means slanted. So when we talk about a right prism, it just means the face is perpendicular to the base, right? So the face and the base meet at 90 degrees as opposed to the face and the base meeting at some acute angle. All right, so if we're going to draw a right prism, I suppose the easiest thing to do is draw a rectangle or a square, then find the center of that rectangle or square and draw another one that is congruent to it. Right, and now we can join all our vertices. And we call this a prism because our top face and our bottom face are congruent and they're joined by parallel faces on the side. All right, so we know this is a right prism because the edge meets the base at 90 degrees. So with our oblique prism, we're going to do something similar. We're going to draw a parallelogram like that. We're going to draw another parallelogram below it that's congruent or close to it. And then again, join your vertices. All right, so now you can see we just have a prism that's been pushed to the side. And so we're going to say that our two bases are those two right there. Now, with this kind of an oblique prism, the height is actually outside the shape or outside the figure. So that's how tall the figure is. Whereas opposed to on a right prism, you can just measure the height right on the side. All right, so there's a little bit more terminology here we're going to need to go over. We're going to draw just one big prism here and label some parts. So let's draw the Superman logo, or at least it's the polygon shape. Looks like this. So find a point right in the center. There we go. So that's a pentagon, but in the shape of that Superman symbol. Or you can just think of it as a regular polygon that's we're looking at it at an angle. Okay, now draw a straight line down, and then draw another parallel line that's parallel to this top one, and join these two vertices. Draw a line that's parallel to this edge. Join those two vertices. And you should have this pentagon shape that looks like we're looking at it from the front, let's say. Now shade in this top. That's a base. And actually, let me draw in our lines in the background. Again, give us more perspective. Okay, so we have our top base and our bottom base. They're both called bases. And so you can call the one on top. It doesn't matter which one you call it. You can just say that's base 1. And over here, or down here, we have base 2. Okay, now we have just an edge. And we call this one a lateral edge. Okay, so that's this piece right here. I don't think I have another highlighter close by. No, that's all right. So we'll use a pencil. And then we're going to say this is one of the lateral faces for this polygon, or polyhedron. All right, base, face, edge, face. All right, next page. We'll just quickly talk about cross sections. Now, a cross section is just basically a slice through the figure, and it can be at any angle. It can be vertically, horizontally, or slanted, okay, or a diagonal slice. When you play Fruit Ninja, right, you slice through the piece of fruit. Fruit separates, and you got some kind of an image or a figure that's you see on the cut piece. So when we come up with a cross section, it's the intersection of a solid and a plane. The plane is that knife or sword cutting through the solid. You can think of the cross section as just a very thin slice of the solid, but this arrowed section represents the slice, right? That's our plane that's going through the solid. And right now it just says, for each solid, draw the cross-section formed when the plane intersects the figure. So if you sliced off the edge of this right prism, what would the shape be on the side of this prism now? Well, you can see that if you cut it off, there would just be this rectangular shape. So this cross-section is rectangular. If you were to cut off or slice off a corner of your right prism here, we'll notice this is an edge, and that edge has to come up here and meet this corner of the slice and meet up that corner of the slice. So if you were to slice kind of at an angle, your cross section would actually be a triangle. And the last one, we're taking a cross section of a cone. In this case, it's just a vertical slice right through the cone. And you can see, as that slice goes right through, what you're left with is going to be a circle. Okay, on to the next part. This lesson is kind of, like I said, before the formulas, it's just some extra information here before we get to the formulas. But this next one is Cavalieri's principle. And it's talking about the volume of prisms, more along the lines of that if two figures have the same height, so or two or more figures have the same height, and they have the same cross-sectional area at every level, so these all have the same area at each height, then every one of those figures has to have the same volume. I don't know how well I can demonstrate this on the camera, but you can kind of think of this as a deck of cards, right? Here's a deck of cards, whatever its volume is, it's the same as when I slant the cards off in one direction, because at every level the cross sections stay the same and the height of the cards didn't change. Same height, same cross sections, same area. So it actually doesn't matter how far you separate it, the height's always the same, cross section's the same, volume's the same. Okay, so we've got prisms, cross sections, Cavaliere's principle, and now on to these 4 formulas, starting with volume of the pyramids. Okay, volume of the pyramid. Pyramids have one base and 3 or more lateral faces. And those faces are always triangles. One thing to know is that pyramids are not prisms. Okay. One of the reasons we know it's not a prism is because at each level, if you take a cross section, the cross sections are different. Whereas here, if you take a cross section at this level, it's the same as the cross section at that level. So with prisms, the cross sections stay the same all the way up. Pyramids, they don't. All right, so with a pyramid, we've got our height, and we have what's called the slant height, or the kind of like the angled height. And the slant height gets the letter L to represent it, whereas height gets H. So our formula is simply this. It is really just 1/3 of a cube, or 1/3 of a right prism. So it's just area of the base times the height divided by 3. Anytime we use a capital B, B stands for the area of the base. Okay, so let's do an example real quick. Find the volume of a square pyramid. That means the base is a square. If the slant height is 26 and the height is 10. Okay. Well, let me show you how to draw a pyramid real quick. If it's a square pyramid and you want to give it some perspective, draw a rhombus. Doesn't have to be perfect because that's all right. And now we just pick a vertex for our pyramid and draw lines all the way down to each corner. And there's a square pyramid with a height of 26 and a slant height of 10. Okay, so what that means is the height of this thing down to the center is 10, whereas the slant height from the vertex to the edge is 26. So if we're looking at this thing, if we're looking at the triangle on the inside, then we've got the height of 10, the slant height of 26, but we need to know this base edge so we can find the area of our square base. All right, well, this is a right triangle, so we can do our Pythagorean theorem. 10 squared plus x squared, 26 is our hypotenuse, equals 26 squared. Okay, so this has a height, or sorry, this has a length of 24, which means our base has an entire length of 48 and 48, because it's a square. And so our base is 48 times 48 times a height of 10 divided by 3. So 48 squared is our base times 10 divided by 3, and you get 7,680 cubic units. And I'm sorry you couldn't see that last part, but there it is. Okay, let's go on to the cone. The pyramid is probably the longer example of all of them. The cone, that's just going to be a solid that has a circular base and a vertex that's not in the same plane as the base. Okay, so here's your circular base. Here's the vertex that's in a different plane. And again, we have a height, we have a slant height. In this case, now we have a radius. So now our volume, just like the pyramid, is just 1/3. In this case, it's really just 1/3 of a cylinder, which is what we're going to be going on the next page. Right? So it's just 1/3 of the volume of a cylinder, which is the area of the base times the height. Well, the area of the base is a circle, and that's pi r squared times h. Okay, so find the volume of a cone if the radius of the base is 8 and the height is 10. Okay, so we can draw our cone. Say that the height is 10, the radius is 8. Well, that's all we need. We actually don't need our slant height to calculate this. So volume is 1/3 pi r squared times height. Now, I'm not sure, I think Khan Academy asks you to actually convert all this to a decimal, which means multiply by pi. Here, we're just going to leave pi in our answer. So 64 times 10 is 640. So we have 640 pi divided by 3 cubic centimeters. And you can, I think, like I said, I think on Khan Academy you have to convert that to a decimal. All right, last two. The volume of a cylinder and volume of a sphere. All right, so the volume of a cylinder. A cylinder is just a solid, again, composed of two congruent circles in parallel planes. So this plane and this plane are parallel. Their interiors and all their line segments parallel to the segment containing the center of both circles with endpoints on circular regions. So this is simply the area of the base times the height. Length times width times height, essentially, but the area of the base is a circle. So volume is pi r squared times h. So in our example below, we have a radius of 8, we have a height of 15, so volume is pi r squared times h, pi times 8 squared times 15. So we get 64 pi times 15, 64 times 15, 640, we get 960. And if you convert that to a decimal, you get about 3,016 cubic centimeters. All right, let's see if we can make this video under 20 minutes. Last example, volume of spheres. Okay, with a sphere, again, the formula is similar to the others in that we're dividing by 3, except for this time it's 4/3 pi r cubed. Now hopefully we're not out of school too long. When you come back, I think it'll be easier to kind of explain some of these, like where that comes from. Right now I'm just going to tell you the formula. So find the volume of a sphere with a radius of 7 centimeters. Volume is 4/3 pi r cubed. So that's 4/3 pi times 343, which ends up being 1372 pi over 3 cubic centimeters. And again, if that was a decimal, sorry, I just left, can't see all that. I keep forgetting to look up at the screen. Oh, I've got like 10 seconds left. Volume is about 1436.76 cubic centimeters. Okay, that's it. Check Schoology for the assignment on this lesson, and if you have any questions, I'll be available on a Google chat. All right, have a good day. Oh, and don't forget to like, subscribe, and hit that bell. All right, bye.